Hey guys, this is Ed from Mission Ed Possible, where I take on various life improving gamified challenges. Welcome to my Go Programming Challenge, Day 4. We're doing the advent of code in the Go programming language. If you're new to the series, be sure to check out the link to the first video in the description below. It tells a lot more of what's going on. Let's do the thing. Okay, Day 4, the ideal stocking stuffer. Santa needs help mining some Advent coins, very similar to Bitcoins, to use as gifts for all the economically forward-thinking little girls and boys. To do this, he needs to find MD5 hashes, which in hexadecimal start with at least 5 zeros. The input to the MD5 hash is some secret key, your puzzle input given below, followed by a number in decimal. To mine Advent coins, you must find Santa the lowest positive number, no leading zeros, with no leading zeros, 1, 2, 3, etc., that produces such a hash. Interesting. Okay, I've never done this before, or anything like that, so let's see how it goes. So, for example, if your secret key is ABCDEF, the answer is 609043. Because the MD5 hash of ABCDEF 609043 starts with 5 zeros, and it is the lowest such number to do so. Huh. Okay, if your secret key is PQRSTUV, the lowest number it combines with to make an MD5 hash, starting with 5 zeros. 5 zeros, even though there's 7 letters? I guess it doesn't matter. The other one had 6. So the lowest number it combines with to make an MD5 hash starting with 5 zeros is 1048970. That is the MD5 hash of, the key 1048970 looks like that's 0000, whatever. Okay, so 5 zeros plus a number. And so the question is, and it says it's the lowest such number to do so. Huh. That's interesting. Okay, so it seems like a naive approach here would be that, let's see, hash. Your secret key is ABCDEF. The answer is 609043. It's the MD5 hash. Starts with 5 zeros. But is there only one? Okay, well, first off, let's see if we can do an MD5 and go. Okay. Block size of MD5 in bytes. Size of an MD5 checksum in bytes. New hash. Sum returns the MD5 checksum of the data. Crypto MD5. These pretzels are making me thirsty. So the idea is with this, that we're going to have to iterate through. Okay, that's interesting. All right, let's see what we got here. Let's do a day 4.go. We don't need a data file because we've got, we're not reading any files or anything. So just got that, and we're going to import crypto/md5. All right. And so let's just copy this for now. So I'm going to say, let's set our secret key. I'm going to set the key equals to ABCDEF, just so we can get through the example. Okay, so we have the key is equal to ABCDEF. And now we want to know the MD5 hash of ABCDEF and that number. So we just add a number. So this should be interesting. Okay, so I'm going to say num equals no leading numbers. It has to start with 1. And so what we're going to do is we're going to say key. I think what I'm going to do is I'm going to say fmt sprint f, and we're going to say %s %d for the number, and we're going to say it's going to be key and num. All right, so we have the byte value of key and num. Okay, and now we're going to print out the MD5 of that. All right, didn't complain really. So let's see. Go run 4.go. Okay. So that came out with 5F8B62 as the start. There's going to be slow. We are working in Go though, so this is a good opportunity to use some Go routines possible. But first of all, let's try to make it work in the straightforward manner here. Okay. So what we're going to want to do is say, I'm going to say the sum equals MD5 dot sum of the data. I could probably, that's a lot. What I could do is make this a little cleaner. I can say secret key. I'm going to call it just secret. And then I'm going to say key equals, and then I'm going to use this here. And we're going to do it that way. And we're going to say the byte value of the key. And we're going to print that out. Okay. just to make sure that we're on the same page here. And I'll go ahead and do like that. Let's see what that looks like. Should be the same exact output. Secret not known. Okay. Yes. Okay. And it has an enter or new line at the end. That's good. Okay. All right. So the idea is that if the first 5 characters, let's see. So we're going to be checking the sum. It says, because if MD5 hash of that starts with 5 zeros, and it's the lowest such number to do it. Okay, so it's the first one that it achieves. That's good. Okay. So the hash starts with 5 zeros. Okay, so all we really need to do then is we need to compare if some, and we're going to have to do a substring of it. So first of all, we're going to need to turn it into a string. So let's see, some, we're going to do a sprint f. Yeah, it should be okay. So we're going to say %x, and we're going to say the sum, and that's going to turn it into a string. There might be a better way to do that, but because it's hex, there might not be a better way to do that. That one's a little iffy. Okay, so what I'm going to do is I'm going to say leading characters, the prefix equals. And what we're going to want to do here is we're going to say, we're going to want to grab the first 6 characters of that, or 6 or 5, I don't remember. 5. And we're going to say if it's 5 zeros, then we care about it. If not, we don't. So there might be a better way to do this, but we probably can use a slice. I don't know if that'll work, but let me print. Let me just try printing it. It's going to be a %s and prefix. Let's just see if it complains. It didn't complain at me, so okay, actually that will work, and we just need to say 6. No, we had it right the first time. It's the first 5 characters. Okay. So now we're going to say if the prefix equals 0000, then we're going to say what the answer is. So what are we looking for? The answer is 609043. Okay. Do I want to call it answer, or what do I want to call it? I guess I'll just call it answer. I'll just go ahead and print it. And this is going to be a decimal number. Actually, it can be string. It's fine. Well, No, it's going to be decimal, so that's fine. And we're not going to print the prefix. We're going to be printing the num. And we are going to go through. We're not going to be printing it out. And what we're going to want to do is we're going to want to do a while loop. And prefix you can do it this way. While prefix okay, it just doesn't want to be equal to 0. Doesn't really matter. While prefix does not equal that. It doesn't look like it likes that while syntax. Golang while. For is goes wild. While rather. Okay. For whatever does not equal that, then do the thing. Okay. Okay. And we're going to put it in there. And then what we're going to do is we're going to output here. And we don't need to do the if statement. But what we can do is we can, actually the prefix will, once it reaches that, we're good. So all we need to do now is say we're going to go num plus plus. Okay. So let's look through the logic here. So we have our secret, we have our number starting at 1, and we have our prefix. Is not equal zeros. Okay, five zeros. Now, the problem here is that if for whatever reason it never gets there, like if it overflows, it will hang indefinitely. So the good thing is I can hit Control C. It shouldn't be a big deal. This may take quite a while to get there. It's hard to say. We've got the prefix that's already established, and then we say if the prefix does not equal 0000, we set it to something that's not equal 0, or not equal those zeros to start. So it's definitely going to get into this loop, and it's going to increase num each time that it does. It starts at 1, and num goes up each time. Okay, well, let me try it. Go run d4. Prefix declared but not used. Prefix declare. Oh, because I'm declaring it here. 609-044. That sounds like almost the right answer. It's off by 1. And the reason why is because we have increased num every time. So what I want to do is to prevent that. What I'm going to do is I'm going to set this up here, and I'm going to say num equals 0. And that way, what it's going to do is as it comes in, it's going to say num equals 0. It's going to automatically increase it to 1. And then it's going to go through the process. Otherwise, num, because we care about the value of num, what we want to do is once prefix has been set to 00000, 5 zeros, we want to exit out of that loop. And once we do, that should be our answer, not after we've added 1 to num, rather. Let's see what we got. 609043. Okay, that's the expected result. Let's just try it for the other example. Prefix, no, secret. PQR STUV. Let's run this. 1048970. 1048970. That looks good. Okay, let's try it then. Let's put this in here. And let's see how long it takes. Okay, it actually didn't take as long as the other one. Okay, 254575. Let's see what we got. Yay! That's the right answer. You are 1 gold star closer to powering the weather machine. Continue to part 2. Okay. First half of the puzzle is complete. It provides 1 gold star. Part 2 is now find one that starts with 6 zeros. Okay, that's pretty easy. All right. There. Now, my guess is it's going to take longer, but we'll see. Prefix, we need to make sure to grab 1 more 0. Now, we could also probably make this a little bit more flexible, but it's fine. I think it's fine. Just to make sense there, let's just do it that way. The input, or the secret, is still the same. So let's see how long this takes. Oops. Day 4, go. Okay. All right. 1038736. That's the right answer. You're 1 gold star closer to powering the weather machine. And we've completed day 4. Yay. Hope you enjoyed the challenge. If you did, be sure to hit the like button. If you'd like to see more of this challenge or any of my other challenges, be sure to hit the subscribe button and ring the bell. I post new videos at least once a week. What do you think about my programming? Be sure to leave a comment below. If you're interested in seeing the GitHub repo, be sure to hit the link in the description below. As always, see you in the next adventure.